Alright, so example 5 asks us to graph the parabola x squared minus 4x minus 2y plus 6 equals 0. And as soon as you see the words graph the parabola, you should know there's two different standard forms that we could possibly have in this problem. So, first thing I'm going to do is establish standard form structures, alright, that I could possibly have. So one of them is x minus h parentheses squared equals 4p parentheses y minus k. The other option is y minus k parentheses squared equals 4p parentheses x minus h. Those are the two choices for standard form. And again, standard form is your goal when you're graphing things because that's easy. It's very hard to graph a parabola in this current form. So I want to get to standard form. And the way I determine standard form is real easy for a parabola, because again we have two choices. If you look at the problem, what's squared? X is squared, which means this is the standard form I'm going to use. You have two standard forms, either x is squared or y is squared. In the problem, either x is squared or y is squared. So if x is squared, use the x squared standard form. If y were squared, we'd use the y squared standard form. So I'm going to throw this one out for this problem because x is being squared. So now my task is to make that problem up there look like that standard form there, and it takes a little bit of manipulation using a few algebra tricks that you've seen before. Some of you have already mastered these tricks, some of you are a little struggling with them, but if you keep on seeing the same thing again and again, sometimes they eventually stick in your brain, right? So let's try this again. So here's the secret to making standard form. It's a couple-step procedure. The first thing you want to do is do some separation. The standard form has x on the left, everything not x on the right. So the first thing I want to do is make that happen in this equation. Since x is squared, I want everything x on the left, everything not x on the right. So I'm going to keep x squared right where it's at, minus 4x right where it's at. I'm going to leave a gap and then put an equal sign. Do leave the gap. It creates room to do stuff so your work doesn't get all sloppy and hard to read. So everything containing x stays on the left. Everything not containing x, specifically 2y and 6, are going to move to the right. And those things that move across the equal sign, according to algebra, have to change signs. So negative 2y moves across the equal sign, becomes positive 2y. Positive 6 moves across the equal sign, becomes negative 6. So that's priority one. Step one in the process is separation. Right? Whether it's x squared or y squared, the one that's squared stays by itself. The stuff that's not squared goes over there. Do some separation. The second step, we're going to complete the square. All right? Completing the square focuses on this term right here, this number. Okay? So just a little bit of vocabulary for you when we're talking about a quadratic equation. We have a quadratic term, that's the x squared term. We have a linear term, that's x to the first power, and we have a constant. Okay? So what we're creating here is a quadratic structure that has the quadratic and linear term but no constant. We want a perfect square so it factors like that parentheses squared structure. That's what we want. All right? So the way we complete the square is we do two things to this number here. It doesn't matter plus or minus, so just ignore the sign. Just worry about the number 4. We're going to do two things to it. First thing, really challenging, we're going to divide it by 2. Okay, start off with the hard stuff. What's 4 divided by 2? 2, right? All right. Then, after we get that number 2, we're going to square that number. What's 2 squared? 4. See, really tough math there, right? So we take this number divided by 2. 4 divided by 2 is 2, and then 2 squared is 4. If that number happened to be 6, what's 6 divided by 2?
3.
3, and 3 squared is? 9, right? So there's a magic number. We find it by doing half and then square. So half of 4 is 2, 2 squared is 4, so we're going to do plus 4 here. And using good algebra, if I add 4 to the left, I have to add 4 to the right. That's our complete the square step. Okay. That's something we've already done this year several times in several different chapters. Some of you handled it quite well, some of you were struggling with it at the time. So hopefully we're at a point now where we've seen this enough times that it's starting to kind of make some sense. What?
What's the 4x with a positive?
And then it was still half of 4 is 2 and 2 squared is 4. You're always going to add. It's always plus something. The sign doesn't matter because when you square, you're multiplying negative times itself or positive times itself. You always get a positive. So it's always plus. Step 3. We're going to factor left, simplify right. All right, so this is the step that a lot of you got hung up on in the factoring part, where we went from the completed square structure, this perfect square trinomial, trying to get into this binomial squared structure. I'm going to try and make more sense of that just to show you. This is what we're trying to create. So we're trying to take this trinomial here and build it into this structure here, some binomial squared. Now, there are three things in the parentheses. Three things. First thing is a letter. Something goes here. Second thing is a sign, plus or minus. The third thing is a number. All right? Those are the three things. And we have three things up here. So if you look at each thing up here and use that to get what we need, the first thing we need is a letter. The letter in the first term is x. We put down x. The second thing we need is a sign, a plus or minus sign. The second thing is minus, so we put minus. The third thing we need is a number, and the third thing here is a number. We take the square root of this number. The square root of 4 is 2. So, take the letter, take the sign, take the square root. Letter, sign, square root. That's how you get those three things. If that happened to be plus, going back to Alicia's question before, if that said plus 4x, we would have had plus 4 here, but the sign here would have been plus instead of minus because that middle term's plus, right? So, letter, x, sign, minus, square root 2. That's how you factor that trinomial. Happens every time. All right? On this side over here, we're going to simplify the right. So that's just going to be 2y minus 2. Actually, I'll probably have this x minus 2 in red. All right. All that I can do on the right-hand side, 2y is a y term. Negative 6 and 4 are both numerical terms. Negative 6 plus 4 makes negative 2. Subtracting because the signs are different. Negative because 6 is bigger. Okay. Notice how we started off here through a couple steps. We're pretty close to standard form. The left-hand side's perfect, right? The right-hand side, though, is not perfect. It's supposed to look like this. It doesn't. Okay, here's what I want you to focus on this. This is not hard to do, but sometimes confuses people. So let me try and make some sense out of this. Okay. The key to this side over here is that has to be y. That's the key. And currently that says 2y. It's not y, it's 2y, right? So what I want to do on the right-hand side for step 4 is I want to make some number times y minus k structure. I want to make that structure happen. And again, I'm focusing on the y. I don't care what number comes out front. I don't care what k equals. All I care about is that y is sitting right there, right after that parentheses. So, looking at the right-hand side, I want this to look like this. That's what I want. The right-hand side has to be equivalent to 2y minus 2, but I need parentheses y. Okay, so whatever this number is in front of y, that's what comes out front. So again, whatever that number is what that number is. That's how I got that 2. If that was negative 2y, that would be a negative 2. It's positive 2y, so it's positive 2. It is whatever it is. So you just pull that off the y, put a parentheses in between the 2 and the y. And to do this, we're having to divide. So the other number over here, the 2 that's kind of hanging out here, I'm going to take negative 2 divided by 2 makes what? What kind of 1? Minus 1, right? Notice if I distributed, what's 2 times y? 2y. What's 2 times minus 1? Negative 2. It's the same expression, right? But again, in order for this to be standard form, that has to be y minus k, so I create it so it says y plus or minus. Again, it could say y plus 15. I don't care what the number is. I don't care what the sign is. I need that to be y. So 2y, pull the 2 out, leave it y, and then divide that by 2 as well. The left-hand side was perfectly fine the way it was, so we leave it alone, x minus 2 squared. And just like that, we got ourselves a standard form. That's how you change parabola general form, which is what this is, everything equals 0, into parabola standard form, the form we use for graphing. So now we get to the graphing phase of it. Graph the parabola. So this is x squared structure, which means it's up or down. I know h equals something, k equals something, and p equals something. What does h equal? Positive 2. What does k equal? positive 1, right? So again, x minus h, x minus 2, h is 2. Y minus k, y minus 1, k is 1. Again, whatever signs are in the structure are the wrong signs, but h is with x and k is with 2. And then 4p, it says 4p and 4p equals 2. So if 4p equals 2, we divide both sides by 4. 2 divided by 4 is a half. I'm going to go 0.5. Okay. When I'm graphing, I prefer decimals to fractions. So I'm going to go with 0.5 instead of 1/2. Okay. What kind of 0.5 is it? Positive 0.5, right? Which means if I had up and down to choose from, which one would I choose? Choose up because down is negative, right? So it's an up parabola. My vertex is h2 comma k1. So 2 comma 1 is my vertex. That's my starting point. So 2, 1 is where I start. The parabola goes up a half. So my focus is up a half. So I'm going to put my focus right here, 1/2 above that. And again, I'm going to put an F and a V just to clarify what those are. If my focus is 1/2 above, where's my directrix? 1/2 below, and my directrix will be what kind of line?
Dash.
Horizontal, vertical, which one?
Oh, vertical.
Okay, vertical's like this.
Oh,
Horizontal. Horizontal, right? So I want my directrix to be horizontal at 1/2 below the vertex. There's my directrix. The axis of symmetry will be vertical because it passes through the focus of vertex. So if you're not sure about the direction of these, if you just always get the axis of symmetry, once you get the focus and vertex plotted, the axis of symmetry goes through those, the directrix goes the other way. So once you see the axis of symmetry is up and down, that means the directrix has to be left and right.
And how do you know that that one was halfway above that? Is it 'cause
It's whatever p equals.
Okay.
So I went p, which is 0.5 up for the focus. I'm going to go 0.5 down for the directrix. The focus and directrix are always the same distance away from the vertex. Focus is a point, directrix is a line, though. So make sure that you're graphing them as such. Finally, I need to know what 2p is, specifically the absolute value of 2p. If I double a half, what do I get? 1. So I'm going to go one space left and right from the focus to get my other 2 points. So here's my focus, one space to the right, one space to the left, 2 extra points to create my up and down, or my up parabola like so. And there's my parabola. All right?
How many did you go off?
I went one right and one left because that's what 2p equals. Because the distance across the parabola at the focus is supposed to be 4p. So you go 2p right, 2p left to be 4p across.
And you go from the bottom dot main?
I went from the focus.
Okay.
From the focus left and right, 1, and then I'm going to connect the 2 dots with the vertex to make the parabola.